All right, Stella, ready to dive into the mysterious world of the periodic table? Dive in. I feel like I'm drowning already. There's so many boxes. Is this some sort of geeky bingo? Well, in a way, it kind of is, except instead of shouting bingo, you get to shout science when things start making sense. I'll believe that when I see it. All right, where do we start? Well, we'll start with the atomic number. That's the little number in the corner of each box that tells us how many protons an element has in its nucleus. It's like the element's ID card. Protons, right. So hydrogen with an atomic number 1 is like the baby of the group. Exactly, it's the smallest and simplest element. And as you move across the table from left to right, the atomic number increases. More protons, bigger elements. It's like a family reunion where everybody's lining up by age. Oh, the old who's older game. Okay, got it. But what's with all those rows? Are they also arguing over who gets the top bunk? Well, not quite. The rows are called periods, and each period represents how many electron shells the atoms of those elements have. Think of them like floors in an apartment building. The element is in period 1, like hydrogen and helium live on the first floor with just one shell. And as you move down, you add more floors, more electron shells. Oh, okay, so they're moving up in life. I like it. Okay, what about the columns? The columns. They're called groups. And this is where things get really interesting. Elements in the same group have similar chemical properties because they have the same number of valence electrons. The electrons in their outermost shell. You know how some people in a family all have the same laugh, right? Well, yeah, the same really bad sense of humor. Exactly. Well, elements in the same group have the same chemical laugh, if you will. They behave similarly. For example, group 1, the alkaline metals are all superreactive because they only have one lonely valence electron, and they're desperate to get rid of it. It's like their Uncle Sammy with a cigar breath. So the needy ones are at the party. Exactly, like, please just take my electron and leave me alone. Sodium's that guy. You know how he is. You put him in water and boom, he throws quite a tantrum. Sodium needs to chill. What about the other groups? Are they all as dramatic? Well, some groups are. Group 17, for example, the halogens, are like the opposite. They're desperately trying to grab an electron. It's like they've got an empty spot in their shell and they're practically shouting, "Give me that electron." So they love to react with alkaline metals forming salts. Wow. Sounds like a real soap opera. Sodium's needy, chlorine's desperate, and together they make salt. Perfect. Well, pretty much. In group 18, the noble gases are like the cool kids at the party. They got a full set of electrons, so they don't need anything from anybody. They're like, nah, we're good. You guys go ahead and have your fun. We're cool. Oh, so they're too cool to react group. Exactly. Noble gases are the chillest bunch. You meet them. Helium, neon, argon. Totally unbothered. They're like, we're full, thanks. That's why we're barely interacting with anything. I could learn a thing or two from them. And what about the middle part? They look different from the elements on the sides. Those are the transition metals. They're like the Swiss Army knife of periodic tables. They do all sorts of things because they have more complex electron arrangements. That's why metals like copper and gold are so versatile. They're like the handy friends who can fix anything. Handy friends, huh? I wouldn't mind having copper around for a few home repairs. Trust me, Copper's a good guy to know. But don't forget, he might turn green on you after a while. Ugh. Noted. And what about those elements way down at the bottom and chilling on their own like they missed the main party? Ah, the Lathorathrums and the Anthrocodicas. They're rare and exotic guests who show up fashionably late. Some of them are used in high-tech gadgets, and others, like uranium, are a little more radioactive. Shall we say, they definitely bring their own energy to the table. Okay, fashionably late and radioactive. Sounds like an unforgettable guest. You bet. But overall, the periodic table is all about patterns. Atomic numbers go up, properties repeat in a particular way, and everything's organized like the perfect little puzzle. Well, Steve, you just turned the periodic table into one of the most interesting soap operas I've ever heard. Chemistry's starting to sound like kind of fun. That's the spirit. Once you see the personalities behind the elements, it all starts making sense. Just remember, every element have its quirks. No pun intended. Just like us. Yeah. And now I'm never going to go back and look at sodium in the same way. Poor guy just needs to calm down. Yeah, maybe one day. Until then, let's just keep him away from the water.